Hello everyone. In last video we understood about the basics of quadratic equations and understood how to solve them. Now in this video let's see the application of those concepts. So we have various types of questions which are reducible to quadratic and they may not directly look as quadratic. Now I've divided all of them into 10 types and let's start with them. So type 1 is direct substitution. So in this type of question you can directly spot the quadratic. For example, in this question x raised to the power 4 minus 5x square plus 6 equals 0, we can substitute x squared as t and we get as t to the power 2 minus 5t plus 6 equals 0, right? Now we can easily factorize it. So this will be t square minus 2t minus 3t plus 6 equals 0, which is t minus 3 into t minus 2 equals 0. So t equals 3 and 2. Now t was x square, so x squared equals 3, which gives us x equals plus minus root 3, and x squared also equals 2, so we get x equals plus minus root 2. So these are the four solutions of this equation. Now try to solve these two questions yourself, then we will solve it. So now let's solve it. Now here in this question we can substitute x raised to the power 1 by 3 as t. So x raised to the power 1 by 3 equals t. So this is t square plus t minus 2 equals 0, and this also can be easily factorized. So it will be t plus 2 into t minus 1 equals 0, right? So we get t equals 1 and minus 2. Therefore x raised to the power 1 by 3 equals 1 and minus 2. So x equals 1 and minus 8. Just cube both sides. Now similarly this question, so this also. So here we can write 7 raised to the power x plus 1 plus 7 by 7 raised to the power x equals 50. And here we now can take LCM. So this will be 7 into 7 raised to the power 2x plus 7 equals 50 into 7 raised to the power x. So I have taken the LCM and also transposed this 7 raised to the power x to the right hand side. Now this becomes now here we can take 7 raised to the power x as t. So 7 raised to the power x equals t. So this becomes 70 squared minus 50t plus 7 equals 0. Now it can also be easily factorized, so the product should be 49 and some minus 50. 70 square minus 49t minus t plus 7 equals 0. 70 comes common here and minus 1 into t minus 7 equals 0. So we get t equals 1 by 7 and 7, and it is equal to x 7 raised to the power x. Now from here we can take log and x comes out to be 1 and minus 1. So this was the first type, direct substitution, and it is the simplest of all. Now let's move to the next type. In this type, the catch is that the sum of the constant terms in these brackets are equal. So 1 plus 4 is also 5 and 3 plus 2 is also 5. Now here what we can do is we can club this and this and these both. So we get x plus 1 into x plus 4 into x plus 2 into x plus 3 equals 120. Now just multiply both the brackets, so we get x square plus 5x plus 4 into x square plus 5x plus 6 equals 120. Now you can see why we did this, so that this, because their sum is same, so the value of this coefficient comes out to be same, and this complete value can be substituted as t. So let's take x square plus 5x equals t. So this becomes t plus 4 into t plus 6 equals 120. This is t square plus 10t plus 24 equals 120. Now this becomes t square plus 10t minus 96 equals 0, right? Now 96 can be we need the product to be minus 96 and sum to be 10, so 96 can be written as 16 into 6, so this becomes t square plus 16t minus 60 minus 96 equals 0. T minus 6 into t plus 16 equals 0. Then we get t to be 6 and minus 16. Now t is equal to x square plus 5x equals to 6 and x square plus 5x equal to minus 16. Now you can solve these both quadratics and get the value of x, right? So I hope you understood the concept behind this, that if we have multiple products and the sum of constant terms are equal, then we can club them to get this common expression, and then we can easily solve this. Now here's the next question for this type. Try it yourself, then we'll solve it. So I hope you were able to solve this. Now let's see the solution. Now here this is x into x plus 1 into x plus 1 into x plus 2 equals 72. Now here again we can see that this sum, and let's write this x as x plus 0, so this sum, these both are equal, and we can just club them and solve it. So this will be x plus 0 into x plus 2 into x plus 1 into x plus 1 equals 72. Now this becomes x square plus 2x into x square plus 2x plus 1 equals 72. Here now we can see this common expression, so substitute it. So plus 2x equals t, so this is t into t plus 1 equals 72. T square plus t minus 72 equals 0. Now we want product to be 72 and sum to be 1, so 72 is 8 into 9, so this becomes t square plus 90 minus 80 minus 72 equals 0. This becomes t minus 8 into t plus 9 equals 0. Hence we get t equals 8 and minus 9. Now similarly just substitute t here and we get two equations, that is x square plus 2x equals 8 and x square plus 2x equals minus 9. Now you can just solve this, and let me tell you the final answer. X equals 2 minus 4 and minus 2 plus minus root of 32 iota by 2. So these are the four solutions of this equation. Alright, now let's see the next type of questions. Now here we have under roots involved. So to solve these type of questions, we need to square them. But squaring should be done smartly in order to avoid unnecessary chaos. Right. So the best way to do that is to keep one root on one side and take everything else on the other side. Right. Let's keep this as one this here and shift this to another side. So this becomes under root 2x minus 5 equals 3 minus under root x plus 1. Now why we did this is because now if we square both sides, so we can easily remove one of the roots directly, right? As compared to if we have squared it here, then it would be really difficult. So let's square this now. So this becomes 2x minus 5 equals square and square 9 plus x plus 1 minus 6 under root x plus 1. Now again isolate this root x plus 1 and square it. So let's solve this first. This becomes x minus 15 equals to minus 6 under root x plus 1. Now squaring both sides, we get x square plus 225 minus 30x equals 36 into x plus 1. Now this becomes x square minus 66x and plus 225, and this also comes here minus 36 equals 0. So this is x square minus 66x and plus this becomes 189 equals to 0. Okay, so now we need to factorize this. So 189 is 3 into 63. Oh, this works. Now we need the product to be this and sum should be minus 66. So this we can just split it like this. So this becomes x squared minus 3x minus 63x plus 189 equals 0. So x minus 63 into x minus 3 equals 0. X comes out to be 63 and 3. Now the catch here is that we may get extraneous root. So what are extraneous roots? That after solving we found some values of x, but some of them may not satisfy our original equation. So in order to find them, we must put these values in the original equation and check which of them are valid. So let's put 3 first. So this becomes under root 3 plus 1 4 plus under root 6 minus 5 1 equals 3. So what we get is 2 plus 1 equals 3, and this is correct. Now let's try 63. So this becomes under root 64 plus under root 63 126 minus 5. So this is 121 and this is equal to 8 plus 11, and this is not equals to 3. So out of these two roots only this is valid and this is extraneous. So I hope you understood. Whenever we square, we generally get extraneous roots. Now why do we get extraneous roots? Let's see. So let me tell you with an example that let's say we have an equation x plus 2 equals 4. If we square both sides, what we get is x plus 2 squared equals 16, right? But this can also we can get this equation by one more way. If the original equation was x plus 2 equals minus 4 and here we squared, still we get this equation, right? So it means after solving this what we get is the roots of this and this, but our original equation was just this. So all the roots of other random equations must be removed, so we must manually check them in order to spot them. All right, now try to solve this question yourself, then we will see the solution. So I hope you were able to solve them. Now this is also very similar, just isolate the first root, and this is equal to 2 plus under root x minus 1. Now squaring both sides we get 3x plus 1 equals 4 plus x minus 1 plus 4 under root x minus 1. Again we can isolate it, so it becomes 2x and minus 2 equals 4 under root x minus 1. So this becomes x minus 1 squared equals 2 under root x minus 1 squared. X squared minus 2x plus 1 equals 4 into x minus 1. So x squared minus 6x plus 5 equals 0. Now solving this we get x equals 1 and 5. Now put both of these values in this original equation and check if we have extraneous root or not. Now let's move to our next type. So in this type what we notice is that these coefficients are same, these both, these both. So what we can do is we can club them and then divide by x squared. So this becomes 2x squared plus 2 by x squared plus x plus 1 by x minus 11 equals 0. So we have clubbed them, and now you can see the pattern why we did this. We did this so that we can get this x squared and 1 by x squared, x and 1 by x, these terms clubbed. Now we can substitute this as t, so let's say x plus 1 by x equals t, and we can now figure out x squared plus 1 by x squared by squaring this. So we get x squared plus 1 by x squared plus 2 equals t squared. So x squared plus 1 by x squared is t squared minus 2. Now let's substitute them. So this is 2t squared minus 4 plus t minus 11 equals 0. 2t squared plus t minus 15 equals 0. Now we want the product to be minus 30 and sum to be 1. So this becomes 2t squared plus 60 minus 5t minus 15 equals 0. 2t minus 5 into t plus 3 equals 0. So t comes out to be 5 by 2 and minus 3. Now t was x plus 1 by x equals 5 by 2 and x plus 1 by x equals minus 3. Now you can again create these quadratic and solve them, and you will get the final answer for the x. Right, now let's solve this next question. This is also exactly similar and you can solve it this yourself. Alright, now let's move to the next type. Now this is similar to a type that we have already seen, but in that type the sum of these constant terms were equal, but in this what you can notice is that the products are equal. 12 to the 24 and 8 3 8 into 3 is also 24. Now we can use this fact, and also we can use the trick that we use in this type of question to solve this. Let me show you how we can do this. Just club them and multiply them. So this becomes x square plus 14x plus 24 into x square plus 11x plus 24 equals 4x square. Right, now here you can see is that x square plus 24 and x square plus 24 are common here, but you cannot substitute them as something because we also have x here, so finding this would be difficult. So what we can do is the thing we did in the last question where we have this similar thing, that that we have divided the all the terms by x squared, so we can get this here also. If we divide by x square, yes, if we divide by x here, this term by x and this term also by x, so we can get similar terms. Let me show you how. So this become x plus 24 by x plus 14 into x plus 24 by x plus 11 equals 4. Now here this can be taken as t and substitute them, then we will get a simple quadratic which can be easily solved. So I hope you understood why we did this, to easily solve this and remove all x square and these x terms using this common values in both of them. Now these were the 5 types, and we will have one more part for this, and we will tackle all the remaining 5 in that video. So I hope you understood them. Now keep practicing all these types of questions, and see you in the next video.